Welcome to Math 104 Calculator Day, where we are now working on Desmos, which is one of your options for a graphing calculator this semester. So with Desmos, we are going to just learn a little bit about how to use it. By no means am I an expert. This is just some of the stuff that we have been using so far. So we're going to type the following equation into your calculator: y equals x cubed plus x. So when you pop into the Desmos graphing calculator setting, which if you don't have that, please see the link for your calculators. You can also type in Google graphing calculator Desmos. It'll come with it. So if this is the screen that you're seeing, we're just going to pull off those little arrows, and then we're going to type in the equation just as you see it. Y equals x cubed plus x. And as you see right here, this is our graph that we are being exposed to. So this was what we can transfer over to this side. And then when it says find an appropriate window, what that just means is, can we see the important bits of your graph? So looking at your graphing or your graph here, what is maybe the primary spot on your graph that we're supposed to be seeing? Right. Well, the big idea is that we want to be able to see this curve and your x-axis, or sorry, your x-intercept. So when it asks for an appropriate window on Desmos, you can kind of gauge it from your x values here, that it goes from -10 to 10. And if it's a little obscure, let me try and move this out of the way. If it's a little obscure to figure out for your y values, just click over to this graph setting right here, this little tool, and then you'll see right here your x and your y axis. So as you can kind of tell right here, we did go from -10 to 10, and your y axis, no wonder why it was a little confusing. They have some crazy decimal places. So if we wanted to, we can definitely change these values to be a little bit more uniform with your x-axis, but by no means do they have to be equal. They can be totally different. We can do this as 20 and -20. Notice that by changing that, your graph will adjust a little bit, and it does look very immediate. Let's say we wanted to play around with your x and your y scale. So right now they are both going up by ones. It is where it normally is. Now let's see if I can get no, these are both on there as well. Yeah, okay, well, let's say your scale is going up by 1. So your scale is by how far these tick marks are. So if I were to reset it and I didn't have anything here, these values here, right, these ones that are in light gray that have no numerical values to them quite yet, these are just the between values. So from 0 to 1, 1 to 2, 2 to 3. So they're going up by ones. And we can show that by putting your step as 1. If we wanted to, we could go up by 2s. And notice that by changing that, it doesn't so much change the x-axis here. It just changes by how fast we're getting to 10, or how slow we're getting to 10. Same thing with your y. Perhaps you go up by 5s. So that just changes this value up here. And we can get rid of some of these minor grid lines to make it look a little bit visually pleasing, or you can keep it. Just make sure that you have something. So by removing your axis numbers, that'll take away everything, but we want ours to show. So we talked about special features being this part right here. If we were to zoom in, which we can certainly, oops, that's zoom out. Notice that if you did zoom out, the most important part of your graph is going to be this little feature here, which no matter how far we zoom in, we're trying to get as close to this value as possible. This most important item on your graph, we're going to call a slide. Now, we don't know why it slides through like this quite yet. We'll learn that in chapter 6, but this would be considered the special feature on your graph. Now, this is also not considered a turning point. A turning point is a change in direction. So in this case, we're not really changing directions. Notice that we're increasing, and then we kind of do that slide I was talking about, and then we veer off and increase. Now, if there was any sort of turning point, we would increase and then suddenly decrease, or the opposite, decrease and then increase. So this this graph has no turning points. Because they have no turning points, we don't have to figure out a coordinate. But we would like to know your zeros, your x-intercepts, your roots. Now on Desmos, once you click around, if I were to click anywhere on this graph and kind of move my cursor, I can find certain points located on your graph. So by moving my cursor, I found a point as 1, 2. Now these are several other points here. It gives you all of the points under the sun, but your 0 is anywhere your graph is hitting the x-axis. Anywhere your y is 0. So by locating it here, it is through our origin. Now let's try it again with this example. So let's get rid of this. I might determine if we can go back to, let's see, a home. Let's see, I could have sworn there was like a reset. More options, lock, no. I could have sworn there was a reset button somewhere. Oh, that's probably why I messed up our steps. Well, maybe I just did it. That looks like it went back to normal. Now let's put the new graph in. So here's your new graph. Again, we're typing it through, and this would be your graph that we're looking for. Find an appropriate window. Does this look like it is an appropriate window? Hopefully, yes. So we can use the same exact window as before. Again, this is probably not the best fit. We can certainly adjust it to be -10 and 10. Now, when we do so though, notice that there is a lot of dead space here. If we wanted to change that out, that is certainly okay. Perhaps we want to get a little bit closer, perhaps -3 or -5, and maybe a little bit visually up. So maybe about 20. That would look also pretty good, as long as we're not somewhere over here where it cuts off, or maybe even here where we see our graph, but we don't see the major point, your major graph here, the major feature of your graph. So how many turning points does your graph have? We have one turning point. Notice that we're continuing down, and then all of a sudden we change directions and then go back up. So we have one turning point. Now, where is this turning point located? Well, this turning point is located here at 2, 0. Sometimes that's special features on your graph. It will give us the coordinates of them already. Notice that these are in gray. This one also happens to be your x-intercept. Now, the other special feature that we might want to talk about is your y-intercept. It is where your graph touches the y-axis, where your x value is 0. So that is another important spot on your graph. Now, this one has another question. It says, find f of x when x is equal to 7. This is just another fancy way to say, well, what is your y when x is equal to 7? So a couple things on Desmos that we can do. Notice that on here, 7 is probably located here, and then we would have to look up. What we can do, other than zooming out a bit, is locating the 7 here, which when we narrow it down, see, sometimes it's a little hard and finicky. And if it doesn't give it exactly right, this is as far as I can go. We can again zoom in. Don't worry, I'm going to show you some other ways to find it. So that's 6. Let's take a look at 7. Again, getting really close to 7 as possible. Oh, that's probably where I was going. Probably wasn't looking at the right number. 7. Getting closer and closer. Come on. Oh, almost there. 725. There you go. Now you can also try it along your graph here. So your equation, if you here, I'll do that again. If you hit this little settings button and then go over where it says create table, when you hit the create table, notice that it has a bunch of values listed for us. Now we should be able to locate where our X values are 7. Let's see, that's zoom fit. Where did we do this the last time? There was a way to get a little bit lower. Oh, there you go. So all I did was just hit enter a few more times, and then there you can see it, 7. Now let's try and do the opposite. So let's say we have a Y value. In our case, let's say we know our Y value, or let's say our Y value is very, very tall, like 100, and we don't want to keep hitting enter so many times. So instead, because we can enter in Y equals here, why not list Y equals 100? So then when we zoom out, if we're not seeing that extra line, because our line should be in purple, we can then zoom out just a little bit and notice that it's going to intersect your graph. Better yet, it's going to intersect twice. So we can kind of see over here another special feature. It's already giving us our point that our values are going to be -8 and 12 for your X values. So big takeaway, if you need X values, so if you're looking for an X value, you can just use your cursor to figure it out over here. Or as we did before, do this create table and try and find your X value that way. If it's a Y value, just enter in Y equals and then zoom out to find where they intersect.